Another solution concentration problem I want you to get under your belt is relatively straightforward, and it kind of reminds me of the spider legs problem. We'll see, or that sort of concept. Let's see if you see that also. Now, this concept of electrolytes, they deal with generally ionic compounds. So an electrolyte is an ionic compound that will dissolve in water, and as those ions are floating around in water, they will conduct electricity. This is kind of along the lines of, if you ever heard that you will not, how do I say this, water, if it's deionized with no ions in it, deionized water will not conduct electricity. It's kind of an interesting concept. So, for instance, ionic compounds, these are examples of two ionic compounds. You know you have an ionic compound if you can find the metal. So here we have a metal here, and here we have sodium's a metal and calcium's a metal. So calcium chloride is an ionic compound, sodium chloride is an ionic compound, calcium nitrate is an ionic compound. Now when these dissolve then, the cations and the anions break apart. Notice that in the case of calcium nitrate, we get one calcium and we get two nitrates. Okay, two NO3s running around. Kind of one of the other things relative to kind of the way chemicals work is, can you see where you get 3 particles over here and you get 2 particles over here? But that's not necessarily my point. Okay. My point actually, yeah, I'll wait till go over here. So this is the sort of problem that I mean. With regard to calcium nitrate, let's just say that you dissolved calcium nitrate in water, and you knew that the molarity of the calcium nitrate was 0.230 moles per liter. Now, does this make sense? I'm just going to eyeball this because we do this in Gen Chem 2 a little bit. Can you see where you get 2 parts of nitrate for every 1 part of calcium nitrate? So can you see where this molarity of the nitrate would be twice of the calcium nitrate? So that's what, 0.460 moles per liter for the nitrate ion. Do you buy that? Well, I'm going to show you how to kind of work that using kind of the stoichiometry, I guess, of the equation, kind of like the spider leg sort of thing. So notice that if we go ahead and unpack this 0.230 moles per liter of the calcium nitrate, that's what that looks like. 0.230 moles CaNO3 2 over 1 liter of solution. So now here I'm going to put a ratio, and I want moles of CaNO3 2 to cancel, and I want to be left with moles of NO3 2 minus here. Oh, sorry, not 2 minus. I'm serious. Minus 1 here. So what numbers go in here from the balanced equation? Yep, a 2 goes there, and a 1 goes there. It's just definitely what we've been doing with equations, balancing or using stoichiometric coefficients as in stoichiometric ratios. So now my moles of calcium nitrate cancel, and we're left with the moles of nitrate ion. Notice what's in the denominator here still is liters of solution. So I have moles of nitrate per liter of solution, which is what? The molarity of NO3. Of course, 0.230 times 2 is 0.460, which is kind of what I said a minute ago. So, okay, so see what you can do with this problem, then kind of related to molarity of ionic compounds.